Welcome back to another video. I'm Dr. Tarcia Hubert, and in this video we are going to be talking about permutations. Okay, so we're going to talk about permutations. I'm going to tell you exactly what that is, but if you watched the video prior to this one, it was about the fundamental counting principle, and I'll put the link in the description below just in case you missed it. But in that video we talked about how to find all the different possible ways of putting things together. So for example, if you have 3 shirts and 2 pair of shorts, how many different outfits can you make from that? And so basically what you do is you take all the number of options and you multiply them together. So now I'm saying that just to kind of give you a refresher of what we talked about before, and then I want to start off with just a little quick example. So I like to watch First 48. I like to watch crime shows. I'm a problem solver. So I like to see if I can figure out who solved the crime or who committed the crime. I like doing stuff like that, putting puzzles together and things of that nature. So anyway, I said that because my first example involves creating a police lineup of suspects, okay? So say you have, say the police have 5 suspects and they want to create a suspect lineup that includes all 5 suspects, all right? So how many different ways can they create that lineup, okay, of those if every lineup uses all 5 people? So if we think about the fundamental counting principle, what we talked about last time in the last video, basically we have 5 suspects, so there are 5 spots. And then you want to put how many options you have for each spot. So there are 5 people. I have 5 different choices I can put in this first spot. So that would be 5. And then if I use one of those people, then now I have 4 people left that I can put in the second spot. And then if I use these 2, if those 2 people are gone, now I have 3 suspects left that I can put in that third spot. And then I've used 1, 2, 3. Now I have 2 suspects left. And then once I have all 4 of those, I'll only have 1 suspect remaining. And according to the fundamental counting principle, you will multiply those numbers together. So you'll do 5 times 4, which is 20. 20 times 3 is 60. 60 times 2 is 120. 120 times 1 is 120. So there's 120 different ways that you can create a 5-person lineup if you have 5 suspects and every lineup uses all 5 people. Okay. So now I said that because that leads into one of the things we need to talk about before we can get to permutations. So anytime you multiply a number and every number less than it, so you see we did 5, 4, 3, 2, 1, it's like a countdown, but you're multiplying all of those. That's called, in mathematics, that's called a factorial. Alrighty, a factorial is, we use the symbol exclamation mark. That represents factorial. But a factorial notation means if n is a positive integer, then the notation n exclamation mark, which reads n factorial, that notation is the product of all the positive integers from n down through 1. So that means n times n minus 1 times n minus 2. So basically you just keep decreasing the numbers each time all the way till you get down to 3 times 2 times 1. Okay, so basically what we have here, you start with the number n and then you decrease it by 1 each time. So 5 minus 1 is 4, 4 minus 1 is 3. But if you talk about it in reference to n, then this is n minus 2. That's 5 minus 2, this is 5 minus 3, this is 5 minus 1. So you do that all the way till you get down to 1. And that is how you find the factorial. So now, there is a factorial button on your calculator. So let me get my calculator. Okay, if you have a graphing calculator, I have a TI-83. If you have an 83 or 84, it's going to be really similar. So say I wanted to find 5 factorial. I'll go to the math button here. Then I will scroll over till I get to where it says PRB, which means probability. Oh, I pushed the wrong one. So I will push 5. I will go to math. I will scroll all the way over until I get to probability. I pushed enter, but then I want to go down to number 4. Y'all see that exclamation mark right there? And hit enter. And so that gives me 5 factorial. I'll hit enter again and you can see it gives you 120. So 5 factorial is 120, and there is a factorial. But on your calculator, now there's also one on your phone Well, I have an iPhone. There's one on my iPhone. I'm not sure if you have something other than an iPhone, but I would still check if I were you, if you're using your phone calculator. Again, remember I told you if you turn your phone to the side, you get a whole bunch of other options. So I'm going to put the 5 in first. And then if you see, there's this button right here. I don't know if y'all can see if it's blurry, but it has an X with an exclamation mark. So I'll push that. And then you can see it gives me 120. So there's a factorial button on your calculator as well. Also, by definition, 0 factorial is equal to 1. So this is defined that way. So if you ever have to use 0 factorial, that's equal to 1. Okay, for our first example, we want to figure out what is 6 factorial. So 6 factorial, according to the definition, is equal to 6 times 5 times 4 times 3 times 2 times 1. So you start with 6 and you go all the way down. That's 6 factorial. Again, you can just plug it in your calculator and figure out what it is. But just for me to write it out so you understand what it is, that's 6 times 5 times 4 times 3 times 2 times 1. You will multiply all of that out. 6 times 5 is 30. 30 times 4 is 120. 120 times 3 is 360. 360 times 2 is 720. And 720 times 1 is 720. And again, you can plug it in your calculator and it'll give you that value as well. So go ahead and plug it in and check and make sure you get the same answer. In this second example, we want to find 8 factorial over 5 factorial. And so basically, we're dividing 2 factorials. Now you can plug them in your calculator just like that. Or you can actually write this out. This is 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1 all over 5 times 4 times 3 times 2 times 1. Now, if you notice in the top and bottom, they both have the 5, 4, 3, 2, 1. So those would cancel, and that would leave you with 8 times 7 times 6. Okay. 8 times 7 times 6. I don't know what that is off the top of my head. Oh, 8 times 7 times 6 is 336. So your answer would be 336. Now, another way you could actually write this, so 8 factorial over 5 factorial is the same as 8 times 7 times 6 times 5 factorial. Because I stopped there because I see the 5 factorial in the bottom. So if I write it out like this, 8 times 7 times 6 times 5 factorial, I see that the 5 factorials cancel out and it leaves me with 8 times 7 times 6. So it's the same thing as what I did here. It's just I don't have to write out the 5 times 4 times 3 times 2 times 1. I see that they're going to cancel, so I just stop and write 5 factorial and then cancel them out and I see what's left. Okay, so that's how you would use the factorial symbol. So those were just 2 quick examples to show you how you would calculate with those. So now let's jump into what a permutation is. Okay, so now let's think about my example that I had about the lineup, right? And I was talking about the first 48 earlier. Now they don't actually do lineups to where people line up. They actually do the pictures now. If you watch the crime shows, you'll see they'll have the pictures of the individuals. So think of a lineup in that manner, right? You're rearranging pictures. But just think about my example. So there were 5 suspects and I wanted to create a lineup using all 5 suspects, okay? Well, say I change that and say there's still 5 suspects, but now I only want to create lineups using 3 people. So now I'm not using all 5. So now the whole process has changed. I'm only using 3 of the suspects, right? Okay, so basically what that boils down to is now I have 3 different options, and I still have 5 people I can put here. Once I use that person, I have 4 people I could put here, and then I have 3 people I can put here. That gives me 3 different options to put there. So I end up with 5 times 4 times 3, which is 60. 5 times 4 is 20, and 20 times 3 is 60. Okay, so if I only want to create 3-person lineups, then that's 60. So now that's not a factorial because I didn't go all the way down to 1. So now this is what becomes a permutation, okay? So when you don't go all the way down to 1, then you no longer have a factorial, you have what's called a permutation. Now the formal definition for permutation is it's an ordered arrangement of items that can occur when 2 things happen. 1, None of the items can be used more than once. So for example, in my lineup, I won't have the same person list in that lineup more than once. So everybody's only going to be used once. So each item that whatever you're discussing will only be used once, and then the order of the arrangement makes a difference. So basically what that means is if here I have, say I'm gonna call person 1, here I have person 2, here I have person 3. So that's one lineup, right? And even though in the other lineup I might have a 3, 2, and 1, I might put 2 here, 1 here, and 3 here. Even though I'm using person 1, 2, and 3, the order makes a difference. I'm putting 2 first, 1 second, and 3 third. So if the order makes a difference, then it's a permutation. Okay. So you have an ordered arrangement. You're figuring out how to order things, put them in a certain order, but none of the items are repeated, and also the order of the arrangements makes a difference. So if you have that, then there is a formula that you use for the permutation. So this formula here that I have, it says NPR equal n factorial over n minus r factorial. So what this means is that this gives you the number of possible permutations of n items taken r at a time. So you have n items total, but you're only going to take 3 r at a time. And so in my example, I had 5 suspects, and I was only going to take 3 to put in the lineup. So my r will be 3, my n will be 5. So in the formula, that would be 5 factorial over 5 minus 3 factorial. So that's 5 factorial over 2 factorial. And so remember, 5 factorial is 5 times 4 times 3 times 2 factorial. I see the 2 factorial in the bottom, so that's why I stopped at the 2 factorial. You see that the 2 factorials cancel, and you're left with 5 times 4 times 3. Which is what I got earlier when I was working it out, thinking about it. 5 times 4 is 20, 20 times 3 is 60. So again, that lets me know I can create that 3-person lineup in 60 different ways, okay? And so this is how you will use the formula to get it. And basically it's the same thing as what I did earlier, but sometimes when you get into larger numbers, you don't want to have to write out every different option. You just use this formula to figure out what those options are, alrighty? So this is the formula for permutation. In example 3, you and 19 of your friends decided that you want to start a internet marketing consulting firm, and then the group needs to choose 3 different officers: a CEO, an operating manager, and a treasurer. You want to find out how many ways can those offices be filled. All right, so there are 3 different offices: CEO, operating manager, and a treasurer. And it's you and 19 of your friends. That means there are 20 of you total. So this is example 3. Since there are 20 of you total, then your N is 20. Well, how many positions are being filled? There are 3 positions being filled. Now, first of all, you have to know, is this a permutation? So remember what the permutation was, that no person will be, no item will be repeated. So meaning you won't have the same person that's the CEO and operating manager. All of these will be 3 different distinct people in those positions, okay? No person is going to serve more than one position. So that's satisfied. The second thing is that the order matters. So if I put person 1 here, person 2 here, person 3 here, then if I switch those up, that's a different option. If I put person 2 here, person 1 here, person 3 here, that's a whole different option, because there's a different person for the CEO, there's a different person for the operating manager. So here the order does matter. So in this case, we do have a permutation. So that means we use the permutation formula, which will be 20P3, or we say 20 choose 3. That means we have 20 items total, we're choosing 3 only. So the formula will be 20 factorial over 20 minus 3 factorial. Well, that's equal to 20 factorial over 17 factorial. So 20 factorial is 20 times 19 times 18 times 17 factorial. So notice your 17 factorials cancel, and that leaves you with 20 times 19 times 18. And again, you could just plug it in your calculator, figure out what 20 factorial is, figure out what 17 factorial is and then divide them. Or you could go through and break it down like I have done, and you end up with 20 times 19 times 18. And so you end up just multiplying that, and you get 6,840. So that means there are 6,840 different ways that those positions can be filled. And here's another example. 9 bands have volunteered to perform at a benefit concert, but there is only enough time for 5 of them to perform. So how many lineups are possible? Alrighty. So we have 9 bands, and we only want to choose 5 of them because we only have time for 5. So is it a permutation? And the reason I'm making you check is because we're going to talk about combinations next. And there's a difference between permutation and combinations. The main difference is the order. Does the order matter? Okay, so first of all, none of the bands will play more than once. Only one band will take one spot. The second thing is the order of the bands does matter. Okay, so if I put band 1, 2, 3, 4, 5, then that's different than putting band 4, 3, 2, 1, and whichever one I'm missing, 5. Because of the order that the bands will go in. Alrighty, so it's not just about which 5 bands will perform. It's about which 5 bands will perform. It's about which 5 bands will perform and the order that they will go in. Since it is a permutation, we will use the permutation formula, which is 9 choose 5 permutation. So that's equal to 9 factorial over 9 minus 5 factorial, which is equal to 9 factorial over 4 factorial. So again, you could just plug those in your calculator and see what you get and divide them, or you can break it down and say that's 9 times 8 times 7 times 6 times 5 times 4 factorial. The 4 factorials cancel, and then that leaves you with 9 times 8 times 7 times 6 times 5. So 9 times 8 times 7 times 6 times 5. If you multiply that out, you will get 15,120. So there's 15,120 different ways that you can line those bands, 5 bands up to perform out of 9 bands. That's a lot of different ways. Okay, now sometimes you can have where some of your items that you're choosing from are duplicates, meaning they are the same. So it won't happen with people because people are different, right? But if you're doing things like trying to rearrange letters or something like that, it might be the case where you have more than one letter. And so in that case, you use a different formula. So the number of permutations of n items where p items are identical, q items are identical, r items are identical, and so on. However many things you have that are repeating, then that formula will be given by n factorial over p factorial times q factorial times r factorial. So these are the things that you have more than one of. So you'll put, that'll be the number. So say I have something where there's 2 a's, then that'll be the number of a's that I have. So it'll be 2 factorial. Okay, so it'll make more sense when we look at this next example. So let's look at this last example. In this example, we want to figure out how many different ways can the letters of the word Tennessee be arranged. Okay, so I have Tennessee written up here. We see that there are a lot of letters that are repeating, and we want to just rearrange these letters, and we want to figure out how many different ways can we rearrange these letters. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9. So our N would be 9. We have N letters in Tennessee, so our N would be 9. Okay, now we have some letters that are repeating. So T, there's only one T. So if we write, so T would be like our, well, T would be none of them because it's not repeating. It's only one T, so it'd be like 1 factorial, which is just 1. So we can disregard anything that we have one of. But E, so E would be like our P. The number of E's would be our P. So we have 1, 2, 3, 4 E's. So P would be 4. Then N is repeating. So that would be our Q. The number of N's would be our Q. We have 2 N's. And then we have S's repeating. So that would be like our R. We have 2 S's. And if we had more letters that were repeating, then we would keep having more letters besides P, Q, and R. You can just call them whatever you want. N, M, so forth. It's just letting you know that you want to count how many of those repeating letters you have, and you want to use those in your formula. So now my formula will look like 9 factorial all over 4 factorial times 2 factorial times 2 factorial. And that's because we have repeating letters. We have letters that are in here more than once. So if we was to work that out, that would be 9 times 8 times 7 times 6 times 5 times 4 factorial all over 4 factorial times 2 factorial. Now 2 factorial is just 2 times 1, so that's 2. So I'm going to drop the factorials and just say times 2 times 2. So the 4 factorials cancel, and then you can start simplifying. Again, you can plug all this in your calculator and do it that way, but I just want to do it most of it by hand. So I'm simplifying. 8 divided by 2 is 4, so I'm going to cross those out and write a 4 in its place. And also 6 divided by 2 is 3, so I'm going to cross both of those out and write a 3 up here in the top. And so that leaves me with 9 times 4 times 7 times 3 times 5. And that's what I end up multiplying. And I get, when I multiply that out, 9 times 4 times 7 times 3 times 5, I get 3,000. So when I multiply that out, I get 3,780. So that means there are 3,780 different ways that we can rearrange the word Tennessee. Alrighty? And so that is how you use permutations. Permutations is about rearranging things and where the order specifically matters. Alrighty? If you have any questions whatsoever, feel free to put them in the comments below. Thank you for watching, and I will see you all in the next video where we talk about combinations.